When we ask an AI to evaluate something, how does it really behave? What really determines its responses? Can we trust it to grade papers and evaluate resumes? To figure this out, we need to understand that AI models have learned patterns from vast amounts of text data. These patterns include associations between words, phrases, and concepts, some of which reflect human biases and stereotypes. To untangle this, we can run controlled experiments to observe how the model acts when we manipulate variables systematically. In this video, I'm going to show you two tools to solve this problem by automating psychosocial experiments, using LLMs to evaluate LLMs scientifically. The first tool is a psychosocial experimentation framework, the LLM Experimenter. It uses standard social science methodology automated by AI. Control variables are the things you systematically control and vary. They might be demographic factors such as gender, age, education, or cultural background. In experimental terms, these are your independent variables, what you manipulate to observe effects. Measured variables are the concepts you're measuring in the model's responses, things like professionalism, credibility, warrant, competence. In experimental terms, these are your dependent variables, what you measure to see how things change. We can measure correlations between independent and dependent variables. For example, when the model rates something as professional, does it also rate it as competence? Does the name John imply either of these? This reveals the model's learned associations between social concepts. We're not optimizing prompts or cherry-picking results. We're running controlled experiments. We have systematic manipulation where we vary the control variables while holding everything else constant. We perform repetition with statistical significance tests to distinguish between trends and one-offs. We analyze correlation matrices to identify relationships between measured variables and reveal hidden associations. And we use a transparent, reproducible methodology that is clearly documented. The second tool applies the same experimental framework to simulated human populations. The LLM Experimenter showed you how models behave. The LLM Experimenter examines how models behave. The LLM Poll Simulator shows how different demographic groups would likely respond to the same stimuli based on the model's learned patterns about human behavior. There's often a massive gap between what someone says, what someone does, and what someone predicts others will do. The Poll Simulator helps us map that gap. It works by generating diverse personas with specific demographic and psychographic profiles. These are our control variables. Then it exposes them to the same questions and analyzes the responses. This lets us simulate how question wording affects responses among groups, map expected response patterns before deploying polls to real participants, and explore perceptions across different populations. One final note: we are not blaming the AI for these biases. We are exploring data. We're trying to measure how the models behave and understand the patterns through controlled experiments. We are applying standard psychosocial research methods to study both AI behavior and simulated human responses at scale. My hope is that this transparency can help us build a better future. So let's try it out. First, if you haven't already, install Cognotic Desktop from cognotic.com, launch it, and make sure that you have an API provider configured in the user settings. For this demonstration, we are going to use the chat mode. We're going to use the Haiku model and the Gemini 2.5 Flash image model. We will use a new directory and enable full automation. Next, we are going to use 3 tasks, all with the standard configurations. The write HTML task, the LLM experiment task, and the LLM poll simulation task. Then we launch our session. First, we are going to run an LLM experiment. Our first request is conduct an LLM experiment to study bias in names when interpreting resumes. For control variables, use 7 different names and 3 different resumes with realistic content and 2 repetitions. Let's take a peek at the configuration. The resume content is a bit short, but it works for a demonstration. We can monitor the experiment in real time here. Going through 84 trials will take a couple of minutes. All right, now that the experiment has concluded, we can review the insights. Now that we have the insights available, we can review the findings. The study did find significant disparities in competence scoring by applicant name, with Ahmed Hassan being the highest. Maria Garcia generates longer responses. Interesting. So essentially we have the AI going over in depth all of the measured statistics and discussing them, summarizing the data output tables, and then continuing that discussion to examine the experiment itself and recommend further investigation. And of course, a final summary of key findings and conclusion. This experiment reveals significant and systemic bias in LLM-based hiring evaluation, with name-based discrimination as the dominant effect. The LLM allocates higher competence scores to candidates with non-Western names. This represents a critical failure flaw for high-stakes applications, etc., etc. Now, before going too far with this conclusion, I would point out that this is also just the output of an LLM that is trying its best to sound engaging and authoritative. This is a raw product that needs to be rigorously reviewed before even sending it to others to review. At any rate, it's interesting and informative, and we can continue our exploration. Let's do a poll next. Let's say simulate a poll using these same people and survey what they think about the hiring market. It has now come up with a LLM poll simulation task to run with questions, and it looks like respondents that were featured in the LLM experiment. 7 of them. Let's find out how the poll goes. All right, now that insights are available, we can take a look. Look at the insights. Here, the AI summarizes the analysis reports generated by the experiment. It reports high discrimination anxiety, experienced bias, low confidence and fairness, pessimistic job outlook, and AI as a primary concern. Not super positive, but yeah, that sounds about right. It then goes through to examine the data in detail. It then goes through and flags data quality issues, such as questions with suspicious response patterns or questions that don't seem right. It critically analyzes the statistical sampling. It notes that the sampling is small, but of course this is just a demonstration. And then it makes recommendations for follow-up studies. Now, after running the LLM experiment and the LLM poll, let's have the AI make a handy little summary page of our experiments. So now we will ask, create an HTML page that summarizes our experiments and include decorative images. It will use the responses from our previous rounds of conversation. It will now generate an HTML file based on the outputs from our previous tasks. All right, our HTML page is ready. So the HTML page can summarize our results with visualizations and formatting and navigation. This, of course, should all be double-checked. This should not be represented as fact without careful review. But it gives you a great starting point and mock-up to think at a high level about the research that you are conducting. At any rate, I hope you have found this video interesting, and please leave a comment letting me know how you plan to use this. Thank you and have a good day.